Hmm. I am about to embark on a very difficult journey right now. I kind of need to because, you know, otherwise, I don't know. The walls of my hallways will be very empty. So let me show you an example. See? Look at all these empty walls. I mean, it's good for like back rooms type of style. Some people are psychologically horrified of that kind of stuff. But in my case, I actually want to start adding things to my empty hallways. And the rooms, I will do that later. But for now, I just want to concentrate on one thing at a time. And that is the hallways first. So look at all this empty hallway segments, right? This is just one corridor. And it looks very plain and, you know, nothing much is happening. So I want to try to fill these empty corridors with stuff. I don't know, I have props. So let me see. If I go into props, stuff like this, I can add a locker in here somewhere. Okay, add some props like that. I mean, we can't run into them, open them or anything, but still, it will look better than like nothing. Also, let me look at this really quickly. That locker looks tiny. If I go into proc halls, hopefully I can see if I go to the walls. The scale is 1:1. So, what is going on? Why is this locker? Is that how tiny it's supposed to look? I mean, if I put in seeker, you can see that the seeker's. This is a really tiny locker. Let me select the locker. Where is this thing? Right here. No, it's 1. The scale is 1. So don't know. It should be a little bit big. I mean, you can't walk inside of it anyways, but still. Why is that so tiny? That's too huge. Maybe something like that. Oh well. Whatever. But anyways, I want to add some props. Some decals. Maybe like, you see how every single wall looks like exactly the same. Maybe this wall can have a decal of paint or something, and this wall can have its paint peeling, and then this one can have some rust dripping down from water, and this one can have a decal of cracks in it, like, I don't know, wallpaper cracking. This, all that kind of stuff. It looks very plain and the same. So I'm going to try to see if I can, because I talked with the AI chatbots, and so let me see. ChatGPT, they all did recommend, you know, procedural set dressing, blueprint set dressing, or I don't know, blueprint procedural set dressing, right? I can just do that in the blueprint. Also, spline-based hallway dressing, but because my hallways are generated very specifically, right? If you go up here like this is how they're generated. One deck at a time, and they're procedurally done with all of these templates here. This is a hallway or a room or whatever it is. These are different types of hallways, segments, and then these are different types of rooms. Well, we're not talking about rooms right now. We're just talking about the hallways. We'll do the rooms later. Fill those rooms with beds and desks and chairs and whatever, lamps. But for the hallways, this is all that's generating them with a bunch of modular custom events, and one begin play, event that goes through each of the decks, generating them, and each of them save information or vector locations into this variable called occupied H. H stands for the hallways. So this variable array only saves the vector locations of every hallway generator. So let me go over here and generate it. Okay, so let's go up to some random hallway. Right, so if we go into, none of these are good examples, but let me see if I can find one up here. Oh my goodness. Oh, here. Okay, so here is a randomly generated hallway. Okay, so we can tell these are not hard-coded. These are procedurally generated. They're randomly made. So they weren't here before. See, if I stop this, they'll disappear. These ones are hard-coded. Okay, so I can do stuff with this, but that will come later. I want to do stuff in the procedurally generated hallways, like these hallways. So, what can I put on the walls here to make them not look the same all the time, other than these rooms? See, these walls are empty. Okay, so can put some lockers there somewhere, randomly placed. Oh, let me stop this. So they are procedurally generated, and each of the hallway vector locations are saved into occupied H. And occupied R I already use for things like this here, random array of items within, so random rooms will be chosen so that I can place these random cosmic cards within them, right? So I can do that for cosmic cards, and I can later do that for beds, desks, chairs, lamps, whatever else that goes into a room. But for hallways, those are different, and they, again, look very plain and empty. Like this. Very empty. As you run through them, nothing much is happening. So, I was talking to the AI chatbots, Grok, Gemini, ChatGPT, and they all recommend, for my specific case, because I have something called an array of vector locations already, so it knows exactly where these hallways are located and how they are formed. So they recommend, like a procedural rule graph type of generation with something called corridor chain detection. So it will go through this occupied H and do some math, finding which one of these walls or hallways connect to each other in a like a straight line, like this, exactly like this. And once it detects it, it saves it, and then from there, it can place, like falling, debris or a whole entire decal that spans the whole corridor rather than just one tile at a time. It can do like this whole entire wall right here instead of just one wall tile. Right, so it can detect that, and that's something that the AI chatbots recommend. So let me see, there are a couple of things. Because my procedurally generated hallways are made with a grid base and they are saved in this occupied H vector location array, then it becomes sort of easy to work with certain techniques. Not so much with spline based or like, yeah, I guess you can use scatter based with anything, but something that the AI chatbot said is good for mine. The technique is the corridor, a run detection or path segmentation, or in my case, the corridor chain detection, which is based off and using rules. So something like procedural rule graph. I can't remember. Let me see if I can look in the conversation. Scroll up in the conversation to see what exactly they say. Oh my gosh. This isn't it. I have to go further in the conversation. Oh my goodness. ChatGPT has a lot of stuff, so let me see. Procedural rule graph dressing. Procedural rule graph dressing. So, and in that you can use corridor chain detection, which others call path segmentation or rule detection. I mean, run detection. It detects the whole run of tiles connected to each other. So let me see if I can go down to the conversation to the point that will help me start creating it now. So let me see. The way you're using occupied H as a temporary per deck array is actually very clean design. The important rule is simply generate hallway layout. So, no hallway, generate hallway. That's it. No hallway, generate hallway. Okay, so the important rule is simply generate hallway layout. Occupied H is filled. So from all of these locations, vector locations, of hallway segments connected together to make a hallway, a completed hallway, then fill that information into occupied H. for hallways. Of course, you do that for the rooms, that will be occupied R. Occupied H is just for hallways. Occupied is for everything. So after I do the hallways and then do the rooms, then I add everything, the hallways and the rooms, to occupied, including these hallways and rooms that are just, they're the skeleton base of the whole rift. Anyways, we'll work on that later. Right now, we'll just specifically work on the procedurally generated hallways, which is what is saved into occupied H, which is, you see there's empty stuff right now. And now you see hallways, which are these. That's occupied H. This is occupied H. So these rooms right here, walls right here, are what I want the corridor chain detection to detect from here to here. Not down to these rooms, because that's the room that's going to be taking it up. You don't want to place a desk in front of this doorway or something. You can put a desk here or a locker here, not a locker here. Alright, so what can I do? Detect the corridor chains, which again, just from here to here, from here to here, and then spawn set dressing, so put stuff in it like, I don't know, decals on the wall, like rusted paint or something, break cracks in the wall, maybe add some containers or crates that span across this whole entire wall, something like that. And then after the whole entire hallway is done, so we don't need to do it with the rooms, but then once we get to these areas of the hallway where it's empty, then we can start placing props again. But once it's done, then go back and clear occupied H so that we can go to the next level and then fill up occupied H for the next level, and then from there, you know, detect the corridor chains in that level, in that deck, and then spawn the set dressing in those, in that level or that floor. So the chain detector runs immediately after the hallway generation finishes for that deck and before occupied H gets cleared. That works perfectly. Now let's build the blueprint logic for the chain detector. Go create a function or custom event called detect hallway chains inputs. Okay. So let me stop this. I don't know if I want to start it here, so I wonder if I should create it in here. I'm going to call it custom event. Custom event. Well, oh my gosh, I lost my place in the conversation. What is it going to be called? Detect hallway chains. Detect. Yeah. I really don't like long names, but okay. Detect hallway chains. Apparently, there's going to be inputs and outputs. How can there be outputs? I only see inputs. Please press the. I need to make a vector array of vectors. I'll just call this occupied H. Pass the actual occupied H array from each of the proc calls into this custom event that is located in player controller. So now the player controller can get this occupied H variable that is filled by this proc calls logic, and now it can start to do some stuff with it. There's also an outputs, which is an array of hallway chain. Oh, okay. I need to create a struct. Go back here to data. Create a struct by going to blueprints and structure. I'll call this S hallway chains. Dun, dun, dun. Hallway chain. Save it. Variables are the start point, which is a vector, end point, also a vector, direction, direction, also a vector, length, which is an integer. What else? Tiles? Optional but very useful later. Okay, I'm gonna just put it anyways. Tiles. This is an array of vectors. So I guess like the occupied H itself, like what? Well, we'll see. An array of vectors, optional but very useful later. Okay, even if you only requested start and direction, store the tiles too, because anchors and multi-tile props will need them later. Alright. Okay, so what do I need to do? Create a data table or something? No. It's just a struct. Okay, required helper function. Create a function. Get neighbor tiles. Input. Tile. Vector. Output neighbors. Array of vectors. Blueprint logic for each of the 4 directions. Let's see. For each of the 4 directions. Positive x is 500, 0, 0. Negative x is negative 500, 0, 0. Positive y, 0, 500, 0. And negative y, 0, negative 500, 0. Check. Occupied H contains tile plus offset. Alright. If true, add to neighbors. Get neighbor tiles. Result, neighbors array. Identify change start points. A corridor change starts when a tile has neighbor count is equal to 2. Why? Because tiles with exactly 2 neighbors are interior straight corridor tiles. Start points include dead ends, corners, and intersections. These are chain breaks and chain breakpoints. Main chain detection event. Create custom event. Okay, so I am here. Need to create the bum bum bum. Create a function. Get neighbor tiles. A function? Does it need to be a function? Can I just make it a custom event? It's called get neighbor tiles. And this one has input of tile, which is a vector. And its output will be neighbors. Parameter tile node neighbors. It's just a regular vector, not a... And the output never mind, will be an array of vectors. Compile. Alright. For each of the 4 directions, check occupied H contains tile plus offset. Contains array Well. I don't have to loop through all of these. That won't work that way. But if it's true, it won't work like this. Unless I call it right away. So maybe I don't even need this function or custom event. I just make the whole thing and detect hallway chains. Huh. Where am I getting tile vector from? Maybe I gotta pass it. Where is this coming from? For blueprint for each of the 4 directions, check. Does that mean I need a for each loop? Dun dun dun. Right here, maybe this. So I probably don't need that. Actually, that doesn't make sense, because that's coming from... Of course it's going to contain this, because it came from this. It's going to contain this array element, because it's coming from this array element. So I need this to come from somewhere else. But where is this going to be called from? Probably here? No. It needs to be coming from occupied H itself. So I don't need to do a contains check. Oh. Oh, yes, I do. Yes, I do. Yes, I do. Okay, so if this... Oh, I see, I see. I have to do some math first. I have to do something like... break this. And add 500. Add 0. Whatever that is. Add it back into here. So let's say if it starts at 500, then if you add 500, that's 1,000. If 1,000 and whatever y is in this array, then it's true, then that becomes a neighbor. If true, add to neighbors. So add array unique to neighbors, like this. don't even need this custom event. And whatever this is at, add it. The 1000 and whatever the Y is. Like that. Okay. But that's only for the X. Now we need to do that for negative X. So that's only for positive X. Now we need to do that for negative X. How to do this? How to do this? Maybe in the loop body, for each array element from this array, we can maybe we just do a sequence like this. First we check the positive X, then we check the negative X, then we check positive Y, then we check negative Y, right? Don't know how that's going to happen though, but let's see if it will still allow me to connect these. Actually it does. Huh, okay, we'll just do that then. X to this, Y to this. Right? Do that, 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 that. So as the sequence checks the positive X, the negative X, positive Y, and negative Y. So put the X back to 0 and then negative Y like that. Contains item. We need to connect this to each of them. If true, add unique. Add it here. Uh-oh. Okay. Guess I have to do this one by one. Alright. And duplicate this. And duplicate these. And then connect this. And then connect these. This one is true. This one is true. If these are true, then add them to the same exact array of neighbors. X goes to X, Y goes to Y, X goes to X, Y goes to Y. I suppose we can just do the Z's. Alright, let's see. Okay, so so that does it on each and every single. Oh my goodness! I was gonna have to do. I need a way to reference this instead, so that I don't have to call this each. What do we call this? This custom event each time, which will run through this loop of hundreds of vector locations that make up the walls. And that's on just one floor. So, detect hallway chains. I guess this is one way to, what is this? Let me put the Z here as well. Okay, so got some crazy spaghetti code here. So then split this up a little bit more. Spread it out a little bit more. How do we get the dun 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 dun. Move this. After each segment or sequence is done, then it goes back to the loop, goes back to the array, and checks the next array element and checks for neighbors. But it's unique, so even though it's checking it all over again, it won't save it all over again. But the thing is, this is saving neighbors as just a whole list of neighbors. It's not checking if they are, well, it is checking if they are next to each other, but it's just going to check every single one of those that are next to each other. And it won't cluster them into, it won't group them into a corridor chain. So let me see, maybe there's more to this. So let me see. Identity chain start points. A corridor chain starts when a tile has neighbor count equal to 2. Why? Because tiles with exactly 2 neighbors are interior straight quarter tiles. Start points include dead ends, corners, and intersections. These are chain breakpoints. Main chain detection event. So this is probably how I will actually detect the... So again, detect hallway chains, create a custom event, detect hallway chains. So it turns out this, what I just created, was the function. But like, how the heck I was supposed to do that without occupied H? Alright, so anyways, the local variables I need are visited tiles. An array of vectors. And hallway chains itself. This one though is an array of the struct that I made. What was it called? Hallway chain. Struct hallway chain. Okay. All right. Local variables, visited tiles, array of vector, right here, and then hallway chains right here. So the neighbors are just a bunch of random vector locations that are all, you know, nearby each other. But visited tiles will be all the tiles that we don't want to go over again. So this is similar to my occupied H. So that I leave out anything that is unoccupied or anything that is a vector location for a room or any of the vector locations for the outer framework hallways. And then hallway chains is the actual array with complete and full hallway chains that do not connect to anything else. So we will take this and see what more we need to do. Main chain event. Okay, so I create the custom event, detect hallway chains. Then I created local variables, visited tiles. Now I got to loop through occupied H, blueprint logic for each loop, occupied H. If visited tiles contains tile, skip. Yeah, but how do I fill the visited tiles? You know what? I'm just going to do neighbors. Otherwise, neighbors equals get neighbor tiles. Check. Neighbors length does not equal 2. If true, this tile is a potential change start. Oh, I see. This is why I need to get neighbor tiles. So that I can check it if it is a potential chain start. Dun, 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 dun. obviously visited tile's not going to have anything, but let's just do it, whatever. Turns out that this is logic that is completely it's something else. Don't need this one. This is like how am I supposed to grab? Maybe that's why this needs to be a function in here. How do I do this? Hmm. Detect hallway chains. I guess it's gonna have to do it because it has to do it anyways for each and every single one of the floors. So might as well just do the logic in here that says to check every element within occupied H. So all the hundreds of vector locations in here, just check it each floor. But hopefully only do it once. How then can I do that? I need BP controller to. Unfortunately, you have to do that after proc halls generates each hallway on each floor. Yikes. So I suppose I have to just keep this for each loop then and run through it. All hundreds of tiles, vector locations for each of the tiles that neighbors wants to check or needs to check. Don't know how I'm supposed to. Well, whatever. Let me just go ahead. So, okay, so blueprint logic for each loop occupied H, right? Occupied H for each loop. For each tile, each array element, if visited, contains tile. Uh, hmm. Okay, so this one needs another for each loop like this. For each loop from the completed, then you do that. Then you can check, but not even then really. So let me move this completely out of the way. Let's just work on this for now. For each loop occupied H, it comes from here. If visited contains a tile. Contain visited tiles contains an array element. Branch. If true, if visited tile contains a tile, skip. So just do nothing. But if false, neighbors. And then that's where we can do this logic right here. Oh, I'm going to have to do that for every single one of the get neighbor tiles. Oh, okay, I see, okay. Alright, so get neighbor tiles on the false neighbors is equal to get neighbor tiles. Dun, 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 dun. How do I do this? This these do not come from here. They come from because these array elements come from here, which is occupied H, which is obviously going to be contained within occupied H. So we don't want these ones to come from here. We have to test the ones that come from visited tiles, which again doesn't have anything in it. If visited tiles contains the tile, skip, do nothing. Otherwise, if it doesn't contain the tile, then get neighbor tiles of that tile that wasn't visited. Well, no, they were all visited, weren't they? So we do this with the for each loop, and Hmm. They confused me. So let me see. Let me see if I can read the. Who else did I talk to about this? I talked to. Let me see, Gemini. All right, so I understand perfectly. Because occupied H is a transient map, quote unquote map, that exists only for the duration of a single DEX generation, the chain detector must run as a post-generation pass immediately after the hallways are spawned and before the variable occupied H is purged. From a first principles perspective, we are converting a cloud of points into a list of vectors with magnitude. This allows the game to recognize that 5 individual tiles are actually one 15-meter hallway, which is the mechanical 5 times 15 meter. Okay, well, whatever. Which is the mechanical requirement for placing larger anchor props. The data structure. S hallway chain. Did I do it? Oh yes, I already did that. It's right here. Hallway chain. Before building the logic, create a user-defined struct named S hallway chain. With these variables, start point is vector, end point is vector, direction is vector or rotator, length is integer. This one doesn't recommend tiles, so we're just going to keep going. The blueprint logic. The chain detector. This logic uses a search and destroy method on a temporary copy of your array to ensure we don't count the same tile twice. Setup. Create a function called analyze corridor chains, which over here we called it detect hallway chains. You know what? This is ChatGPT's method. Let's just create another method, a custom event, and call this one analyze corridor. You know what? I can't say if it's too small. Corridor chains. Let's just follow this one. Input your current occupied again, and with the input, I need occupied H. This needs to be an array of vectors. Local variable temp occupied H, a copy of occupied H. This one doesn't have a temporary copy, so I'm going to make it. Temp occupied H is an array of vectors. Okay, good. Output hallway chains, array of struct, hallway chain structs. Yeah, okay. Okay, we got that. All right. Loop, the logic flow loop while temp occupied H length is there such a thing? While loop. Oh, I guess there is. I have no clue what I'm doing with loops. Length. Array occupied H is whatever the length of the array is greater than 0. If it's true, loop. Is that what you want? That's what it's saying, so I'm assuming this is what they're asking me to do with this loop, this while loop, instead of I suppose I could just do this with a for each loop or something, but oh well. I'm just going to follow word for word what these instructions are. Loop while temp occupied not this occupied H. We want temp occupied H. However, we first need to create occupied H, and we can only do that when we first call this, because we can't do that in the construction script, because this doesn't even exist yet. The procalls doesn't even, the occupied H was not even created yet. So, suppose I have to set temp occupied H. This way, alright, you know what? I like to use sequence, so we'll just do sequence. Even though it's still exactly the same thing. Temp occupied H. There, it's set. Now, we go to the second thing, which is this while loop. We call temp occupied H. Now that it's been filled by occupied H, you know what? Okay, do it like this. If the length of this temporary occupied H is greater than 0, then loop. If it's not, then it's completed. What are we doing this now? Get index 0 as your current tile. Check neighbors, look for current tile plus 500 and current tile minus 500 on both the X and Y axes. Okay, they didn't tell me to create a current tile variable. How do I find out what the index is? I don't think while loop is good for this. I think we need a for each loop, because then at least the for each loop gives us the index of whatever occupied H is, or temporary occupied H is. This one just only gives the length and not the index. And then the while loop node doesn't give any array element index. Oh my goodness. Shoot. So what now? Then we... You gotta be kidding me. We get... we really don't need the length. We just do a for each loop. Jesus. Oh my goodness. For each. Like this. Like this. And we get the index. Check neighbors for... Now this doesn't even work You, it doesn't work this way. Index will only ever be 0, 1, 2, 3, 4, 5, 6. Adding 500 to that. I don't know if that tells me what the next index is. So pretty much this logic is this logic right here. Jesus. But I don't know why they think that I can get an index from just this while loop. Maybe it's a specific type of while loop. No, this is the only while loop that there is. Is there another type of loop? Get loop. For each loop, for loop with break, while loop, for each loop, map, for each loop set. No. I can't do it with this. And I also can't do it with an array index. I actually need the elements. So that I can test the x and y separately. My goodness. Gemini. Don't know. Maybe hallucinating. So whatever the current is, add that. Add 500 to that. Add negative 500 to that. Add positive 500 to y, whatever y is. Add negative 500 to y, whatever y is. So right, so that's pretty much this logic here, but let me see what current tile plus or minus 500 in both the x and y axis. The run detection, if a neighbor exists in the x and y x-axis, start a chain in that direction. Continue searching current tile plus 500 times n until the result is not in temp occupied. Record and purge. Save the start, end, and direction into your S hallway chain struct. Crucial step. Remove every vector used in this chain from temp occupied H. This prevents the scanner from finding the same hallway twice. Alrighty. So, this is actually the difficult part, and they are not explaining it well. This is the part where I actually create the hallway chain. Each hallway chain within each of the procedurally generated hallways from just one floor, And I'm gonna, oh my gosh, I can't, I don't know, the darn, like, um, math to this. Well, I know the math. Like, oh, the logic. I don't know the logic. If a neighbor exists in x-axis, start a chain in that direction. Mm. Hmm. 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 Do, 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 do. So again, I think I'm going to have to do it this way by using the sequence, placing it into, what am I placing it into? If a neighbor exists in the x-axis, start a chain in that direction. Continue searching current tile until the result is not in temp occupied H. All right. Let's see. So, again with the sequence. And I gotta compare this to something, don't I? I need a, but what to what? Okay, so if this x is added to 500, and it is contained within temp occupied, if this x this is x, but it is the same as this x, but it is at 500 to the right. If that variable is, if that vector location is contained within temp, okay, so let me do that. Contain. No. Let me do it this way. Contains item. Break it. If this x is contained within here, oh my gosh. Oh boy. You know what? Oh my gosh. Jesus Christ, we gotta do all of this. We're gonna need that, and we're gonna need another. You don't need to add it. You simply just drag and drop to this. Only the y is what we're looking for. That is different. I mean, the x is what we're looking for. That is different. Then, if true, if this is true, then we add it to the we don't actually have a neighbors for Gemini. This neighbors is created by ChatGPT, so I'm gonna just borrow it. But that's not what the logic is saying. The logic is saying directly, if it is contained, that means that the direction, since it's on the plus 500x, that means it's on the x direction. If it is on the negative 500x, that means on that direction. But if it's on the positive 500y, that means it's on the y direction. So what it's telling us to do is completely start it here. Start the chain here. If not, do nothing and go back in temporary occupied until it does. And also, if it does, so we create the S chain hallway struct hallway chains. Oh my gosh, so we gotta add unique to hallway chains. We gotta break it up. And we gotta break this up. And maybe even break that up. And then so lengthen tiles, I don't know what we need to do with that, but okay, so if it does contain, it is contained in the temporary occupied H itself. Then we add that as a start point. Oh, no, not the add. We don't add the add. We add the original. The original x, not the added x. And the original y. And the original z. We add that to hallway chains, and we tell it this is a x direction. Why is direction in a vector? Let me see. Direction. Oh, actually, yeah. Direction is a vector. So what do they mean by that? How do I... Uh-oh, lost my place. Here we go. Start a chain in that direction up. You know what? I'm just going to say, give it a number here. Length is, I don't know. I suppose we needed the length after all. How do we know what the end point is? Hmm. Wow, this is so very confusing to work on. What is this? The index of the newly added item, or index none if the item is already present in the array. So if the neighboring x is contained within the same array, then it's true, then add that to hallway chains. Oh my gosh, this is so... This is so difficult. How am I supposed to find out the endpoint now? Hmm. So if it's going to be 500, then we know the endpoint cannot be negative 500. And if it's on the x, then we know the endpoint has to be like 500 to 1,000, I guess. No, that's assuming. What to do? What to do? 1, 2, 3. How about we just make it? No. Yeah, actually, yeah. So this is 500. It is. Then the next one over is 1,000. So we take this x, this, take this x, add 1,000 to it. Like that. Add it to the end point. Let's say that will be the end. So whatever the x is the start point. When you add 500 to it, that's the middle point. And then when you add 1,000 to it, that's the end point. That's not how it should be done because there could probably be more. After this, I will have to remove this x. Mm. So it has to be the original, not the added. actually, it also needs to to remove any of these. Shoot, I did this wrong, didn't I? That. Just remove it right away. Now. There's going to be some crazy. Crazy. Spaghetti code here. It's going to be crazy spaghetti code. Crazy spaghetti code. So, this is the new X with the 500. And this is the newest X with the 1000. Got to be removed as well. But their Y's and their Z's are going to be exactly the same. So whatever they are. Right down here and right down here. Then the Z is here and the Z here. Alright. Now that is just for one of the checks. Now I gotta do these other checks here. Oh my gosh. Oh boy. Dun dun dun. I don't think I'm gonna. I don't know. Jesus, this is going to be crazy. Let's me move all of these. All the way up, all by themselves up here somewhere. Okay, and then I can move it up somewhere far off. And duplicate. For the next one. This one will be negative 1000. This was coming from X, right? This goes here. This goes here. Y goes to Y. Z goes to Z. X goes here directly. Y and Z directly. That's the first thing to be removed. X comes from here. then y comes from here, and z comes from here. X comes from there, y comes from here, z comes from here. Okay. I think that's everything connected. Oh, we need to connect the temporary occupied H. We also need to connect the sequence up here. Right. Then duplicate. Oh my gosh, we still have to do some more connections up here. Huh? So, again, if it is behind it, that means we take the original as a start point. The original location as a start point. The end location is minus 1,000 to it. And the y and the z are the same. Y, z are the same. Now we do for the y's. Positive y and negative y down here. So we go like, oh, we already did copy. So let's duplicate this one. This one here is for this. And this one here is for this. This is negative, negative, and this one is positive and positive. Right, and right, you get the y's to connect here. Oopsie, we don't connect it there, we connect it here. The x connects directly here, the y connects here, the z connects here. Don't need that. Go away, go away. Alright, so now we simply take the original for the start point. And the end point will be, this is y. X goes directly there, y goes here, and z goes directly there. And, oh, you know what, I forgot to change all these. This is a positive 500 on the y. It's a 0. That means this is a negative 500 on the x, because this one is the positive 500 on the x. So, and again, this is the positive 500 on the y, and this is the positive negative 500 on the y, which means this is a 0 on the x. Alright. What else do I need to connect while I got this here? X goes to x. Y goes here, which goes back to y. Z goes to z. And then the x here is directly from the x at the start. Y is directly from the y. And the z is directly from the z. the end x is directly from the start. However, the y comes from this y. Let me see, does this connect to y? Yes. And does this connect to z? Yes. Alright, so now we connect the rest by, we have to remove the original. We have to remove the original x, y, and z. From here, x, y, and z. And then from here, that should not be an x, that should be a y. We remove this y. The x comes from this x, and the z comes from this z. And what comes from here is the y. This one is the x, and this z comes from z. Alright. Alright, so everything connected. Is this connected? Is this? Yes. Alright, temp. Again, these do not go to the x's, they go to the y's. These go to the y. Back up here. This connects to y, and this connects to y. Alright. So it's y, y, y. I know that comes from the original, and then this is y, and then this is y. Alright, so this is connecting to the negative y. This x comes from this. This was z comes from this. This is the original x, the original y, and the original z. This is the original x and the original z. But this one is the y comes from here, which goes here. This comes from this y. Also, this is the same. This y comes from here, and this y comes from here. Okay. So now, what we remove is the original x, the original y, and the original z. The next thing we remove is the original x, the original z, and the plus 500y, or the negative 500. This is negative. Next is remove the original x. Is that right? Yes. The original z and the negative 1000y. And that's it. So these corridors will only have 3 tiles, just to make things not as complicated. And that's it for one of the elements. But it just keeps going through all the elements until hopefully this is completed. Now, how to do the length? I don't even know. We'd have to do... Again, since they are 3, so 0, 1, 2, 3, either we type in 3 or we type in 2. Then the length is always going to be just the first one, 0, the middle one, 1, and and the last one too. So I guess. Let me see. How? No, I deleted the length. Length array. Length of length of where is length of, oh, here we go. Length of array. Get the number of items in an array. So if it's 0, 1, 2, 3, 4, that means it's 5. So, what happened? Please stop. Stop selecting this. Oh my gosh. Right. So that makes these 3, a length of 3. 0, 1, and 2. That is a length of 3. Tiles. Are you kidding me? That's pretty much this. That's pretty much this, the middle one, and the last one. Do I need to? For now, I'll just leave it empty. Alright, so some of these are not connected. Let me see if I can. This is 500. This one is going to Y. So this goes to Y. And this goes to Y. And then you can. Oh my god, they were already connected. Oh my gosh. There we go. This one connects to Y, but I don't think I need to do it since this already connects to Y. So I simply just delete this one. Alright. So now I got this one, this one, this one, and this one. Those are all the do. Index rate, don't need it. So, alright. If neighbor exists in x-axis, start a chain in that direction. Oh, let me make sure. Negative 500, positive 500 on the y. Negative 500 on the x, positive 500 on the x. Okay. If a neighbor exists in the x-axis, start a chain in that direction. Continue searching current tile plus 500 times n until the result is not in temp occupied h. Record and purge. Save the start, end, and direction into your S hallway chain struct. I didn't save it into the hallway chain struct. I saved it into the array of hallway chains structs. First step, remove every vector used in this chain from temp occupied h. This prevents the scanner from finding the same hallway twice. Add to array. Add the completed struct to your hallway chains output array. Now I just directly added it right here. I didn't add it to a struct separately. Once you have the hallway chains array, you can dress the floor before clearing occupied h. Logic loop through hallway chains. Right. So now that all of that is completed, hallway chains is filled. Now I loop through hallway chains if length is greater than or equal to 3, meaning 1500 centimeters or longer. The anchor spawn, calculate the midpoint, start plus endpoint divided by 2. Spawn each ISIM instance, place your anchor. A massive rusted ventilation shaft or a collapsed hospital gurney cluster. The clutter pass around that midpoint. Use your raycast grounding to scatter small non-colliding debris like torn wallpaper or shattered glass. Alright. So you know what? Since I am not using this one, I'm going to delete this one. What else do I need to delete? Gamma value, rarity, weight, neighbors, and visited tiles. No, I don't need neighbors. I don't need visited tiles. I did everything in the logic of this custom event. Analyze corridor chains. Let me take this whole darn thing, move it up here. Then I can move this one down here. So I have some space to work with. Alright. So once this loop body is completed, that means this hallway chains will be filled with whatever corridors are present. Then we check after that is completed. Then we go branch off of the completed and we go to for each loop from the hallway chains that we just created. And then for each of the hallway chains, each element in the hallway chains, It's probably 1 or 2 or 3 or whatever. Probably at the most 2. At the beginning of the hallway and the middle of the hallway. I mean, at the end of the hallway. So at the beginning and the end of the hallway, there's probably most likely a hallway chain. So there's probably 2. So loop through each of the 2 hallway chains in this hallway chains array. And we have to do math. So in order to do that, we got to break this. And we got to get the direction. Undo that move. Undo the move. Oh my gosh, you cannot be serious. You know what? There we go. Alright, the direction. The direction. How do we do this? Calculate the midpoint. Spawn HISM instance. Place your anchor, a massive rusted ventilation shaft, or collapsed hospital gurney cluster. Around that midpoint, use your raycast grounding to scatter small, non-colliding debris like torn wallpaper or shattered glass, managing the temporary existence. Since you clear this variable for every deck, your level generation manager should look like this. Generate layout, your current protocols, occupied age, fills, logic, fills occupied age, run chain detector, identify the 50-meter runs, execute dressing, add HISM anchor props, and wall clutter using HISM. Finalize stacks, place seeker monster start points. Purge clear occupied age to prepare for the next deck. By using HISMs, the props remain in the world even after the array that helped place them is deleted. The array is the scaffolding, the HISMs are the building. Optimize neighbor check rules for hallway change. Using the directions stored in your struct, you can apply smart dressing rules. Chain direction. X-axis run. Check neighbors at Y 250 and Y negative 250. Snaps pipes and electric conduits perfectly to the long walls. Length equals 1. Check all 4 sides. Identify small closets or intersections for individual props. Length is greater than 4. Place anchor prop at index 2. Creates a focal point for the seeker in long hallways. Alright, next step. Would you like me to provide the math expression node logic for calculating the midpoint and rotation of a chain so your anchor props always align perfectly with the hallway walls? Since your hallways can be X-oriented or Y-oriented, the rotation logic is vital to prevent props from clipping through the walls. Yeah, that's true. But let me get to this first. Loop through hallway chains. If length is 3, meaning 15 centimeters or long, true. I mean, all of these are going to be true. There's only 2 in here, and they're all going to be true. But you know what? I'll just do it anyway. If it's true, then do everything else. If it's false, skip this one and go to the next one. But Most likely they're all going to be true. Um, so calculate the midpoint, start point, first. I need to find out the direction. If it is equal to positive, let's just do the first one. Positive 500 on the x. If this is positive 500, that means it's going in the positive 500 direction. Okay, so if the length is true, that is greater than or equal to 3, then continue. If not, do nothing. Just go to the next element in hallway chains. Alright, so if this is true, then check if this is going in the positive x direction. If it's true, then do this math. If it's not true, then check if it is in the negative direction, negative 500 direction. If it's true, do stuff. If it's not true, then duplicate and duplicate once more. This one is in the positive 500 direction of, if it's true, do something false, go to the next check. If true, do something false, go to the next check. If true, do something false, go to the next check. And if true, do something, but if it's false, it shouldn't be false because it should be one of these. And if it isn't, then it's going to stop and it's going to go to the next hallway chain. All right, but this one checks off of the X. These ones check off of the Y. So positive 500 on the Y or negative 500 on the Y. All right. Save that. Okay, so if it is true, then we do the math of, we add the start and the end point together. Start and the end point of x. Since we checked it on the x, we take the x, start and end point. So we add it together. Let's say it's 0 and 500. 500 divided by, 0 and 1,000. So that is 1,000 divided by 2. Is 500. Alright. And then where do we do this? That's the new x. And that's where we spawn. If true, we do this math. And we spawn. No, we don't spawn. We add instance. Dun dun dun. We don't even have the actual. we're not going to add it here. We're going to add it in proc calls. That's here we just do the logic. So we just say set. We don't even have a variable. We got to create the variable. What do we call this variable? This one, is it a vector or is it a... We need it to be a vector, not an array. True, do the math and set the... Let me just do this. Set vector like that. Split it. This becomes the new x. And the y and z comes directly from... No, the y and z are going to be the same, so it doesn't matter if I take it from the start point or the end point. But let me see. It's only the start and the end point that will be different. The y and the z will be the same for the start and end point. So, oh, you know what? It doesn't matter. Just take it from the start, because they're exactly the same. The only ones that are different is the x. So that's where we did the math calculation for it. There. You move this a bit out of the way, like that. Then in proc calls, I have to call this corridor chain. But you must call it at each. So once we generate this south rooms, north rooms, hallways are completed here, so we can either call it here before any rooms are connected or generated, or after all the rooms and walls are generated, then we'll just call it here at the very end. Analyze corridor chains. You cannot call it. Apparently you have to cast a player controller. Oh, it does it for you. Well, not really. Still have to call it. Get player controller. What the heck? Player index. What are you doing? This is proc calls. Okay, compile. Alright, okay. I guess you can't just call a function. You have to cast to it first. So we can cast to it once, I suppose, in construction. Maybe? Will that work? Cast to BP player controller player controller. No, you cannot call it from unfortunately you cannot call the player controller for some reason. You can't call it from the construction script of of these subset blueprints. For some reason, I don't know why. It's plain stupidity, but doesn't allow you to. So, unfortunately, you will just have to call it directly from blueprints. Not blueprints, but you'll have to call it directly from the event begin play, maybe? Let me see. Where is event begin play in this? Oh, I know where. It's this thing here. So before we go to the sequence, maybe we can cast to BP player controller. And then hopefully we can call player controller. Yes, there we go. And either we can save it as a variable called player controller reference. Complete it. That. So at the very start, now we can reference play controller variables. Good. Compile. And at the very end, before the next one comes up, then we can call player controller that way. Oh, then we also have to pass occupied H. Hopefully after everything is done, occupied H will be filled. Like that. And we save it. So by the time occupied H is done, we can call analyze corridor chains, brings us back to the player controller. We pass the occupied H into temporary occupied H, and then we do all this logic to get hallway chains, and then once it's completed, we go through hallway chains, and then we do this logic, and that's just one of it. Now we need to do the rest. So how do we do the negatives? The negative is going to be interesting. Let me see. Let's say we start with 500. And the next one is 1,000. So the next one after that is 1,500. That becomes negative 2,000 divided by 2 is negative 1,000. Okay, so it still works. All right, so we simply do the same thing here. Just duplicate that here. But put the true on here. we take again the x and the y. It doesn't matter which one because they're just being added together. Like that. And then pass the x and the y. I mean the y and the z. Doesn't matter. Doesn't matter. So long as it's y and z. Alright, so now for the y axis, they will also use the same. We connect this here, move this here. But this time, instead of on the x, we are going on to the y. So if y is checked here, we take the starting y and add it to the ending end y here. Divide that by 2, add it there. And then this takes the x and the z, which should be the end x and end z should be the same as the start x and start z. So just doesn't matter. Make sure it's x to x and z to z. Then there. Is that it? So now we copy this, duplicate it. On the true, we connect this. And still we get the x and the y. Still, I mean the y, negative and a positive y. Where is it? Start point y, end point y. Make sure this is the same. End point y, start point y. End point x, start point x. Start point x, end point x. Okay. And then they do their calculations, and then we go and take the x, give it to the x, take the y, z, give it to the z. And that should be it for setting the anchor locations. Now that we got the anchor locations of each and every one of them, of the anchor of the hallway chains, let's say there's only 2 in here, and this logic will go through the loop body and it will complete. What is this? Oh, that's a direction. We don't need direction. Z direction. Only X and Y. So anchor location and anchor. So the anchor location, even though they are the exact same variable, will be determined by these branches. Which one of these exact same variables will we use? Will we use this one, or this one, or this one, or this one? So it depends on what the direction we take. We take a positive y or a negative y, or a positive x or a negative x. And if we take the negative x, that means we take this specific anchor location and discard the rest. This one will be passed back to proc halls from this chain, this custom event here, which then we can spawn. You know what? There's gonna need to. There needs to be a lot more to this than. Whoops! Do not delete that, please. Do not delete it. Undo to delete. Just move it down. It's Alright, so it went through all of them. Made an anchor location. But only for one of them. So let's say if there's two in here, there's two hallway chains in here. That means only the last anchor location will be saved and passed back to Brock Halls. So, hey, this is going to be interesting then. We cannot spawn things from here. How do we pass that? Back. There, I don't see any output to be passed back. Shouldn't that be the, I'm guessing this is why we need a function maybe. Functions, I think, can pass things back. I think, I don't know. Oh, here we go. Yeah, functions can pass things back. They have outputs. Construction script as a function? Oh, I see. I didn't know that. But apparently you cannot pass things back to it, unfortunately. So I might need to do this as a function. Convert event to a function. Where is it? now we can pass back the pass back the anchor location. So this anchor location can be passed back to, first of all, we need to, yikes, how do we do this? Where? Oh, here it is, okay. Right. It's a vector. It's a single vector. We save. Save. Can we do multiple? That's fine. Let me see. Can we duplicate this? Looks like we can. Right. Connect. 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 Alright. Compile. Here's the anchor location. Now we can spawn. Add. I don't actually have anything. Let me just add a add a corner. Delete that. Add location to location. We'll just add a corner here. Just see how things go. Just test it. We're not gonna do any props just yet. We'll do that later. I need to end this session soon because I need to go eat. Alright, so once we got that compiled, Then we save all. Then what do we do now? Delete this, build everything, save all, and then we test, and we see. Actually, we gotta wait for... The monster's not here. Anything with 3 tiles should start. Alright, so it looks like it didn't work. So I have 3 tiles here. You know what? Maybe it's showing up on the wrong side. Let me see. No, it's not showing up at all. One, two, three. 1, 2, 3. Maybe it needs to be longer. This is pretty long. Let me see anything on this side. It should spawn. At that location. It should spawn it at that location. Okay. Let's go ahead and stop this, and yeah, do some sort of like debugging, I guess. Hopefully it will tell me. How many anchor locations spawned and where they spawned, if they did. If not, we will see right now. Spawned only on the first floor. 2,500. Okay. 2,500 at 500 all on the same floor. It should show up in here. Maybe not. Maybe it doesn't show up in here. Oh, okay. Fine. Where is... Where is it? Oh, here. Is this it? Let's see. It spawns right there, just like that, at that rotation. So imagine if this was a decal, then that would go across this. But why does it only go across here, not any other points? If the logic found more than one monster should have found this to be 1, 2, 3, or 1, 2, and 3. No, maybe this 1, 2, and 3. Okay, let's say this 1, 2, and 3. Should have spawned something here. Say that's 1. This is 2. Maybe that's 3. 4, 5, 6, 7, 8, 9. There should have been 9 that it found, but I only seen it listed 4. And each of the 4 anchor locations were the exact same, and so it placed it here at this one. So if that's 2,500, and this is going on in the direction of the Y, if it's the direction of the Y, that means we change this to 0, and it should move back. So, oh, it moved here. Okay. That's right, because this going down is positive, going up is negative. Right? If that is 0, this is 500. That means this one covers that wall, this one covers this wall. That one is 1,000. Alright, so that makes sense. So for the purposes of why did it do it only on one floor? When it passes, okay. So it passes the one floor here, right? And it goes through, and it does all its logic here. Then it does its logic here, then it goes up here, and then it finally goes to here, and finally to here. Now, apparently it found 4 when I found 9 hallway chains or corridor chains, but the logic only found 4. And for some reason it placed the anchor location all at this exact same spot. So another thing I might need to do is in here before that we need to we need to do break vector break this link, split the struct. I suppose it really depends. No. Whether it's positive or negative. We'll see. We'll see. On the Y at least, we will see. Add. Z goes directly here. Duplicate. Is up here. X goes to X, Y goes to Y. Because we won't do anything for this X, but for the Y, you add a negative 250. This time, let's see if we can actually add. Other than a corner, we don't have it. We have to actually add something. But let me. Okay, if we're gonna have to add something, let me add. Let me look through. Let me just look through. Let me see if there's a painting that I can use to put on the wall. Dun, dun, dun. Could have sworn there should be a painting in here somewhere. Ceiling. Huh. Oh, here's a painting. Painting 01. Alright. So we go ahead and add HISM. Call it painting. And we will use that mesh of the painting. Let me see. What? Why does it look like that? Looks horrible. Looks more like a mirror. Oh. Okay. As soon as I selected it, it messed up the image. Where's the image supposed to be like? Didn't it look like a beach or something, or a tree? Now it looks weird. It looks like nothing. Let me go back here. Let me go back here. Let me look at this painting. It should look like this tree. So, change this. 512. 2. 2. Doing some texture prep because whatever I got these from the Unreal Marketplace or the fab.com, I just directly input it into my game. I didn't bother preparing the textures for my game, so I don't need it to be 2K by 2K or 4K by 4K or 8K by 8K. I only need it at max 1024 by 1024. So now that I got that, let me get this and look at the base color. Let me see, what is this? What is this? This is a texture, but it's like really tiny and it's like I don't know. It's RGB. It's an RGB mask. Okay. What else? Okay, we get this. What is this? Also tiny. That should work though. And what is this? Also 128 by 128. I don't need to adjust that. I guess I have to go through all of them. Opacity mask, normal, CTF, and normal. Interesting. I don't think any of these. Alright, so let me go back. That is so interesting. I don't know how do you get the actual material then? It comes from here. Warning, base color samples, painting as color, RM samples, painting as masks. Yeah, isn't that what it's supposed to? Okay. Dun dun dun. Hmm. I think that's the back side. No. Which side is the back side? I guess either side you can display. Hmm. Wall painting, which looks like it comes from here, but nothing seems to fix it, fix this image. Apparently, it wasn't broken. Um, oh man, I don't know how the material instances work. It should show these, but it's not. Wall painting 01. this thing. So I'm just going to take that, save that, painting is updating, okay. Alright. So now that we compile this, and then we delete that, rebuild everything, save, and look for where it shows up. 1500 by 1500, 7500. by 1500, 1700. Where is this painting again? $1,500 by 1,500 by -75. Right, let's go. Let's see where it is. Down there. Should show up here. Showing up in the wall. Should show up in the middle here if this is where it's going for. So if this is the middle, that is south, that is north. Alright, so that's south, that's north. Then this must be on the X, which means this is 1500. This is the middle of this and this. So that means 2000 should be here and 1000 should be there. Let's see. Yeah, 1000 is here, 1500, and then 2000 should be around here somewhere. Because it divides by 2, which makes it 1500. Right here, but I don't want it there. I want it 1750. $17.50 and $75 and want it there like that. So So it should look like this. The decal should show up like this, so that the walls don't look so plain. You get some random pictures showing up like that, or not even pictures, it could just be rust on the wall, or water drippings, or paint, or wall scribblings. And if it was 1515, that means I have to give the X 250 and the Y 15 plus 15, but you don't change it here in proc calls. You have to change it in. So 250 on the X, positive 250, and positive 15 on the Y. So you don't change it here like this is. You just move it. You change it on the player controller here. So if it is on the X, it will be a positive 250 here. It's also hard to tell on which wall. And then this one you add a negative 250. Oh, I'm an idiot. That's for the Y, not the X. It doesn't matter which X you take, just take an X. Because they're the same. Start X or end X are the same. Alright, also for the painting, I need to change the Y. I need to add. What did I add? Added 15. Add. Take this Y, add it here, add it to this Y, like that. And then for the Y axis, we'll find out later what we need to change on the X to get that painting. But I don't know if it matters what side of the wall, but we'll see right now. Negative 250, 1515, negative 7500. Negative 250, 1515, 175. It's in the middle of a wall. I mean, a doorway. Just shouldn't be. That is interesting. I wonder why, though. I didn't even... Okay, there we go. I thought changed it. Guess not. Why did it move it in the middle of a wall? Doorway. It's probably the math is wrong. So let's try it again. $27.50. 30.15. Try it again. Negative 27.50. 30.15. 175. Let's go there. Yeah, that's how it should look. But where is it? Where? It should look like that. But where is it? Oh, I think I know. It's probably at the bottom somewhere. Oh, there it is, at the bottom. Because I didn't add the... So what I'm going to have to do is... If it's at negative 75, what do I need to do to 175 minus 75 negative equals... I need to add 250, I guess. So 75 negative plus 250. Yeah, plus 250. So there's mine, and there's the procedurally generated one. So I will do this in player controller. We have to change the... We have to add 250, duplicate, whoops, duplicate, yikes. Oh my goodness. Okay, duplicate and duplicate. Move these down for these guys here. I don't know where to put it. Oh my goodness. Oh, there's no space. Yikes. I'm gonna put it way off to the side here like this. Z, 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 and Z. And then these get connected to any of these Z's. Like that. And these get connected to this Z. Like that. Alright. Let's see now. Compile. Save it. This might need to be compiled again. Compile. Save. 1750 and 15. In fact, it should be exactly these numbers, negative 1750 and 15. Negative 1750, 15, 175. Let's go to it and see. Interesting. Again, it shows up in the middle of a doorway. But this time, oh, this is, I don't know why, but mine got weirdly adjusted. There we go. 0, 0. So for some reason, this is considering this a place to put this, but that's not supposed to. Alright, well, I'm seeing what is going on, and I will have to talk to the AI chatbots about fixing these. Oop, there's the monster. And see why it is. Maybe I did something with all my logic here, this crazy logic here. Not maybe, I'm pretty sure it's my crazy logic here that messed everything up. So I'm going to have to go back to the drawing board, meaning I'm going to have to talk to every single one of those AI chatbots again to see what I did wrong and see if they can help me fix this. So that's pretty much it for me for now, because yeah, I don't know what else to how to fix it, because it's doing several things. It's showing that it's always finding 4. So I wonder if it's because of these 4 of each sequence. And then there's a problem of it showing up in the middle of a doorway, just hanging in the middle of a doorway. So that's a problem too, and I'm going to have to describe that to the AI chatbots to help me fix what's the problem. But yeah, other than that, let me see. Because I already did the math to have it be placed in the correct spot. It's just there's different math somewhere else that is saying that it needs to be placed in the middle of a doorway, which is it's not supposed to do. That is not that is not a corridor chain. So I'm going to have to figure out what is wrong with that, or at least get the AI chatbots to help me. But other than that, I am done. I gotta go get something to eat. Thank you for watching, guys. Until next time. Bye.